All right, so we're going to talk about heat pumps for hot water. This is Module 3. First, I'd like to bring you through a little introduction. What are they? The history of heat pump water heaters. Then we're going to talk about installation guidance, some basics from the field, show some little movies on how they get installed. And then I'm going to talk about the client benefits. First thing to understand about heat pump water heaters is they're not electric resistance water heaters. They don't just burn a little toaster element that makes the water hot. They instead are like next generation solar thermal collectors, like the panels up on the roof. Instead of collecting heat from the sun directly, a heat pump water heater collects the heat from the air, or potentially from the ground if it's a ground source heat pump, but most of them are air source heat pumps. So look how the energy is flowing in this little illustration here. You get 2 to 5 units of heat energy from the air. Air gets pulled through with a fan, and then there's super cold refrigerant that's absorbing heat from the air. So there's 1 unit of energy that goes into the heat pump water heater to do this work of chilling the refrigerant and pumping it around. And then from that process of collecting heat from the air and adding some energy into the machine, you get 3 to 6 units of heat energy stored in the tank. If this is electric resistance, at the end of adding 1 unit of heat, you'd have maybe 0.95 units of heat in there. That's electric resistance. This you have 3 to 6. So that radical, completely different efficiency rating is what makes a heat pump water heater still compliant for code in California. The old electric resistance types were essentially banned in 2016's energy code. So I'm going to lead you through a little history of how we got here. First off, the first heat pump water heaters were being used to chill beer. They were invented in Brooklyn, New York, and it was to keep the nation's largest beer brewery going with really chilled beer to hand out to people. So this gigantic machine was used to compress refrigerant, pull heat from one place to another, and chill the beer water. The next development that we see of heat pump water heaters is in Switzerland. As you recall, Switzerland is not involved in World War II, and so they get to continue on making really neat technologies while the war is just fighting all around them. And they didn't have access necessarily to oil because of the various war efforts that were going on around them. They couldn't get oil into the country. So they started developing large hydroelectric dams that are up in the Alps. Got huge dammable rivers coming out of the snowmelt. And they used those dams to make tons of extra electricity and turned around and said, for 1 unit of electricity, we could get 2 or 3 units of heat if we used a heat pump into our municipal swimming pools, to heat our city halls and our auditoriums and such. So you see a lot of development of heat pump water heaters in Switzerland in the 1930s and the 1940s. There isn't a whole lot of new technology development until about the 1970s. They had been using heat pump water heaters essentially in reverse to chill milk in Wisconsin. It was the Dairy Equipment Corporation that had already been taking the chilling process of making hot milk out of a cow cold and then sending it off to the factory to be bottled. Well, that heat that they were pulling out of the dairy, you would store it and they'd use it for wash down, wash off all the areas where the cows are, make the whole place nice and sterile and clean. So the Dairy Equipment Corporation in the 1970s starts modifying their existing products and turning it into just a standalone where they would pull the heat out of the air and then they'd store it in a tank of 80 gallons of hot water. That technology was loud. It wasn't very well supported. It didn't go very far in the United States. But it was picked up by a different company, Stiebel Eltron. So in the 1980s, the grandson of the largest water heating company in Germany, which is Stiebel Eltron, he comes to the United States to go to college. He decides he doesn't want to leave. Vermont's so wonderful, but I want to stay in the family business. I'm going to innovate a heat pump water heater. I've just been seeing that demonstrated by the Dairy Equipment Corporation, and I'm going to try to distribute this nationally. So that tank still exists today. That manufacturer is still doing some of the most advanced heat pump water heaters, very efficient, very quiet, etc. The next technology change we see is about 15 years later. It's over in Japan, And Japan has an unusual grid. They don't have access to oil. They don't have a whole lot of dammed rivers. They're mostly burning coal and nuclear power. Both of those energy resources make for a very flat, stable grid. You just have to keep the coal plant on, you just keep the nuclear plant going. But people act differently over the course of the day. Specifically, you go to work and then you come home. And when you come home, energy use spikes all over Japan, all across all countries, essentially. People start cooking food. It gets dark out, so they turn on the lights. They start having family entertainment. All those contribute to a spike in the grid at the end of the day. But Japan couldn't afford that spike. They need to find some really super efficient water heaters, because electric resistance as one of those loads, people come home and take a shower and wash dishes and such, it was making the grid not stable. So they invested in a super efficient new type of heat pump using carbon dioxide, same chemical that's causing climate change. They just stored a little bit of it in a heat pump. And CO2 is different than most refrigerants. It can go to super cold temperatures and it can go to super hot temperatures. So they're able to put a heat pump water heater outside in the snow and get that water up to like 150, 180 degrees. The reason they really want to do this is because the Japanese have a different bathing culture than you might see in the United States. First, people shower, then they get into a sitting tub. The sitting tub might have 50 to 150 gallons of hot water in it. So this ritual of a bathing process makes for a really large demand of hot water. So these CO2 heat pump water heaters, they could produce a lot of hot water. They could do it at any temperature outside. And those technologies have come into the United States, but honestly, they're still sized for the Japanese bathing style. So you see this type of heat pump water heater, the carbon dioxide type, you mostly see that in small apartment complexes or ganged up into larger apartment complexes, not so much people's bathing. In 2002, a year later, another innovation happens in the United States. The Oak Ridge National Laboratories figures out how to make a heat pump water heater about 20% more efficient. And it gets commercialized by the EMI company, and they call it the Watt Saver. So I have little specifications here up on the slide, and you can see it's still a 208, 240 volt product. It has electric resistance backup built into it. It's not only a heat pump, it's also electric resistance backup. And that electric resistance backup is why it needs a 30 amp breaker. At the time, they were getting energy factors of 2.4. That was better than the 2.0 that we'd been seeing back in the 1980s. The next stage of innovation is about 8 years later. And you see heat pump water heaters come out from all the major manufacturers. They're in the same efficiency range. There's a slight range in how noisy they are. Some are quieter, of course. They come in different sizes, like 40 to 80 gallons. And now there's competition. And the competition that we've seen since about 2011 is around efficiency. We've gone from an energy factor of 2.4, which means 1 unit of energy in gets you 2.4 units of energy stored, up to about 4.5 in 2021. That's all because the major manufacturers were trying to one-up each other and get access to the best rebates around the country. In 2012, we see a different innovation, which is computers being added to heat pump water heaters. They start getting bigger. What a computer can do is take the refrigerant below freezing. Usually that's hard to do because the compressor will freeze up. It's below freezing, it's got a super cold liquid in it, and frost will develop. Well, you can solve for that by running a refrigerant backwards, so hot refrigerant goes through it for a few minutes to get the ice off, or enclosing it in a warmed space, maybe a little electric resistance element that's down there. And the computer, its role is to make the compressor go faster and faster. The pumps are going to go quicker. They're going to cycle more refrigerant back into the machine outside to deal with the fact that the temperature is dropping and there's less heat available. So essentially the addition of computers, which they call inverters, that's the name of it, but they're little computers. The addition of computers in 2012, it starts to make it so that heat pump water heaters can be used for hot tubs, and they can go up into snow country in Canada, and they can essentially operate in all the range of temperatures that you might see CO2 operate, but not quite as cold and not quite as hot, to be honest. There's still, CO2 is pretty much the ideal refrigerant for cold and hot. In 2012, you start seeing heat pump water heaters take over the world. So if you go to Hawaii, many of the hotels that you might stay in have heat pump water heaters now. Hawaii is kind of interesting because it doesn't have any fossil fuel resources. And the law of the United States is that any oil that gets delivered to Hawaii has to come on an American boat. So there's a pretty small number of boats that are coming from the mainland all the way out to Hawaii carrying oil. And as a consequence, you have some of the highest fuel prices of anywhere in the United States in Hawaii. So the innovation of cutting the energy demand by 3/4 and sticking in a heat pump water heater, that got adopted pretty quickly around the islands because it was replacing electric resistance. So these bigger central heat pump water heaters have now been installed all over the world. They're manufactured in many different countries, and you can see great examples of them like at this resort in India or this high-rise in Hong Kong, this really lovely hotel in Vietnam, this massive hotel in the United Arab Emirates near the airport. So in between 2012 and 2021, things just steamed along, products got more efficient, didn't change dramatically in how they worked or what they were up to, just got more efficient, until 2021, when for the first time, the home residential market has had access to a 120-volt heat pump water heater. All the other products are 240-volt. They need to be because essentially they're an electric resistance water heater and a heat pump water heater. They're a hybrid of both. And the electric resistance water heater needs 240-volt electricity and lots of it. But we've seen that this has posed a challenge to retrofitting existing homes because you don't necessarily have a 240-volt electrical line delivered to the place where the water heater is right now. Usually there's only a 120-volt around there. And this raises the construction cost and the construction timeline. It happens first with installing a 240-volt line, and then you get to the breaker panel and you have to put in new breakers. But what if there isn't space? Well, then you have to put a new breaker panel. And what if this new increased amount of electricity that you're adding to the house, what if that is actually more than the house has delivered to it? Well, then you have to get a new service wire delivered to the house. These costs, they start to stack up where you think you're just putting in a heat pump water heater, but you're really upgrading the electrical system for the whole house because it uses a significant amount of electricity. So the innovation that's coming out now in 2021 is not the existing 4,500 watt heat pump water heaters, but 900 watt heat pump water heaters. So they're using 1/5 as much electricity to get the same job done. And instead of being 240 volt, they're 120 volt. And the combination there pretty much guarantees that they can plug into any outlet in the house, just a 120 volt outlet, can handle 900 watts without any special wiring or a dedicated circuit. Just plug it right in. And you can just keep on moving. You don't have to have the electrician there and the plumber at the same time to get the heat pump water heater installed. If you're interested in the larger heat pump water heaters, the CO2 types, this is a little installation video that you can check out. Those heat pump water heaters are most appropriate for, really cold environments or when people have large hot water demands. Check it out.
So inside the existing water heater, there's two of these. These are electrical elements. There's one here and one here. And they just immerse inside the tank filled with water, and they heat up the water like an old coffee maker, The new tank is going to look very similar. The bottom 2/3 is going to have an element and an element, but on top of it is a thing called a heat pump. And this is like an air conditioner. You put a window air conditioner and it pulls heat from inside the building and dumps it to outside. In this case, we're going to actually find heat that's inside the garage and transfer it and dump it into the tank filled with water.
Perfect, because there's plenty of heat in this garage.
Right, and this will actually help to cool and dehumidify the garage too.
Great.
All right, so this will carry most of the load, except if you have some case where you got 2 or 3 showers in a row and it can't keep up, and the backup elements will be there just if needed.
Okay.
And it's got a real energy story too. This unit, as a heat pump, will probably cut your electrical consumption for hot water by half.
Wonderful.
So let's start by turning off the electrical power to the old water heater, turning off the cold water, draining it, and cutting it out of here. tip of my thumb, don't cut it. You're a pro. Hear that? That's the heat pump that's on. I got the water back on, the electricity to it, and now it's running, okay? So here's our water heater. I want to take you through some of the things we did. I added a new shutoff valve right here. It's a ball valve. It was an old gate valve before. With a ball valve, you can close it, you can open, you can tell which direction, okay? Cold water comes in right here, and it actually comes all the way to the bottom of the water heater right here, and it gets heated and comes up this way. You can see right here, it leaves through the top and goes out to the faucets right there, okay? There's some important safety devices that are on any water heater, tank type water heater. One is this. This is a vacuum valve. Now this is designed so if you ever shut the water heater off and it started to cool off and contract, it would break the vacuum so it wouldn't collapse, okay? And the other thing is this. It's a temperature and pressure relief valve. Critically important. The most important device on it is designed to relieve at 210 degrees temperature. That's just below steam, or at 150 pounds pressure. So if, in either case, if you got to those levels and you didn't have a valve like this, it could almost become a bomb. So this is the most important device to keep running. There's also an additional valve right here. It's an additional relief valve. Anytime we heat up water, it needs a place to expand. Most houses, it expands backwards through the cold water main, but you and your neighbors have these things called check valves on the water mains coming into the building so that the water can only go in and not go backwards. So there's no place for the heated water to expand. Now we've always used a thermal expansion tank up in New England, but here in Florida, this is what they use. And I think that's really what was leaking, you know, because it was cold water running through outside. So we've replaced that, that's fine. And now you can see there's an additional source of water you never had before, and that's from the heat pump itself. Okay. When this is running, there's a byproduct called condensate. And that condensate will come out through any of these two drains and go to that same drain to outside, all right?
Wonderful.
All right, you're gonna have plenty of hot water for you, your wife, your daughter, and you're gonna save a lot of electricity, all right?
Thank you for coming to Celebration.
All right.
Appreciate it.
It's been my pleasure. I wanna hear from you how the savings were too.
Absolutely.
Okay, be good.